try to create a performance testing strategy, teams would either have the option to focus on either doing back-end performance or front-end performance. But what if you can do both? So what if you can find that sweet spot so that you can have a holistic overview of measuring your application's performance, both from the back end and the front end perspective? So let's start with backend performance. So essentially, when you are testing for backend, you're targeting the underlying infrastructure of your application. So this could either be testing a microservice, it could be testing a database, or an infrastructure that is not necessarily exposed to your users. When you talk about backend performance as well, so this not only provides you with information on your application's latency or your application's response time, but it can also give you insights on different aspects of your application. So, for example, it can give you information about your application's scalability, how available your application is, the elasticity, the reliability, and the resiliency as well. So just to expand a bit on some of these key, concepts. So when we talk about scalability, this is when you're trying to measure your system's ability to add, to remove, or to reconfigure, any of the hardware, software, or any other resources to make sure that it can handle the increase or the decrease in the usage. And then when we talk about elasticity, for example, so this is your system's ability to be able to automatically scale up and down to meet the demands from your user. And then when we talk about resiliency, so this is when your system can basically react to failure and still remain functional. So if you look at this, when you do backend performance, like there's a lot of different attributes that you're also covering. So it's not just about measuring how quickly your APIs or your database can return the specific responses, but it also covers these certain attributes. And then when we think about load testing types as well from a backend perspective, so there seems to be some misconception that people might have around performance testing versus load testing. So when we think about load testing, it's just one part of performance testing. So performance testing is the umbrella term. But then under performance testing, you have a specific type for load testing. And then underneath load testing, there's also different types of load testing that you can perform. There's smoke testing, there's the load testing or average load testing, and then there's also stress testing, spike testing, and then we also have soak testing. So I'll give a quick introduction about these different types of load testing. So the first one is called smoke testing. So smoke testing from a load testing perspective, this is where you verify that your system can handle the minimal load without any problems. So this is quite useful, especially if you want to verify that your test script doesn't have any errors, or you want to verify that your system still works as expected, but you don't want to introduce the average expected load. You just want to make sure that your system still works if it's been exposed to a minimal number of load. And then load testing in itself, I think this is one of the most common load testing type that's out there. And this is basically checking how your application is behaving if it's been exposed to a normal or typical load. So it's quite useful when you have situations that you want to assess the performance of your application, and then you want to identify areas of degradation during like ramp up periods. So it's quite useful to do load testing in those cases. And then stress testing on the other hand, so this typically assesses how your system performs at its limit. So this is when you want to verify that your system can handle the the maximum expected load. So the expected load in this case is, higher than the average traffic. So, if you have situations or if you have systems that receive higher than usual workloads on, events such as if you've got like HR system that, processes like paydays or, like end of the work week, we have to submit like our timesheet. So this might cause a above average traffic. So performing stress testing in those cases are quite useful. And then there's also spike testing. So this is a variation of the stress testing, but the main difference with spike testing is the load is very sudden, it's very abrupt, whereas with stress testing, it's quite a gradual approach. So you do spike testing if you want to verify that your system can survive if it's been exposed to a sudden and a massive rush of like resources. So it's quite useful when your system may experience events such as Black Friday sales, or if you have ticket sales for like famous bands or like famous music artists, where you know that you're going to receive a high amount of traffic in a short period of time, then it's quite useful to perform spike testing. And then finally, you also have soak testing. So soak testing, so this is concerned with your system's reliability over a much longer period of time. So this is quite similar with, let's say, a load test, but then with soak testing, you try to extend that test for much longer. So the time is extended, and I've seen some scripts where they try to do soak testing for like 2 hours, even like 6 hours, just to see if they find any like memory leaks or any like intermittent issues that might arise. Now we move on to front end performance. So when it comes to front end performance, this is where we verify the user experience mainly on the browser level, because this is what mostly our users use on a day-to-day basis. So with front end performance, this focuses on everything that your users see, whether they are accessing your web application on a laptop or on other devices. So this might involve automating like certain user interactions. So for example, we can navigate to a page, we can click on a button, fill out a form, and then you want to measure what is the response time after a user fills out the form. How long did it take to basically render the important components that you're showing on a browser level. So when it comes to the front end performance metrics, the metrics that we track from the front end performance is quite different from what we track from a back end performance. So when it comes to front end, it's important to understand the core web vitals. So these are like the golden signals when it comes to front end performance. And the current core web vitals. So we have largest contentful paint, or LCP, which basically measures your application's loading performance. And then you also have first input delay, or FID, which basically measures how interactive your page is. And then there's also cumulative layout shift, or CLS, which basically measures your page's visual stability. So when we look at front end performance, like there's obviously like other metrics to consider, but what Google has done is they've created these set of core web vitals that every website must adhere to. Or else there's gonna be some SEO like ramifications, like your visitor count might drop and they might go to a competitor website. So you need to make sure that you need to familiarize yourself with these different core web vitals. And the good thing as well is, in terms of like learning, you also need to make sure that you are up to date with with the different metrics, because I think next year they're going to change first input delay. So they're going to remove that and they will replace that with a new core Web Vital called interaction to next pane. So just, it's good as well to basically know all these different like industry standards, so you can keep yourself up to date with all the different changes.